Hi everyone, Jules here. So I want to have a little chat about whether or not having your genes profiled is going to help you. Now, just to give you a little bit of background, in the human genome, in other words, all the genes that we've inherited, as humans, we inherit about 24,000 different gene sequences. So a gene sequence is a series of nucleotides, but if you were to imagine that they were beads of different colors, and what they do is they code for proteins. So our body can use that as the pattern to make our proteins. And what's important, it's not just proteins like our muscles, it's also our hormones and our enzymes. And we look specifically at our enzymes because enzymes really are the workhorses in our body. But what's particularly interesting is that even though we inherit around 24,000 different gene sequences, these gene sequences code for more than 100,000 different proteins. So what this means is one gene sequence codes for more than one protein. And in actual fact, it depends on how that protein is folded as to what the protein is ultimately going to become. So our gene sequences are not exclusive to one particular protein. Now, in addition to our 24,000 gene sequences, we also inherit around 1 million SNPs. Now, a SNP stands for single nucleotide polymorphism. And really what this is a single variation in that sequence. Let's say, for example, that sequence is coding for an enzyme. That means that that enzyme is going to be a bit suboptimal. It doesn't mean the enzyme won't work at all, but perhaps the enzyme is not going to work as well as it would if we hadn't inherited that particular SNP. So it affects the efficacy of essential enzymes and metabolic processes. But what is helpful is that those SNPs can be influenced by the food that we eat, hormones, exercise, and of course, our attitude as well. So what we want to do is that knowing what SNPs we have means that we can minimize the negative influence of that inherited SNP, and we can encourage the positive influence of that particular SNP. So when we profile our genes, we look at the most clinically relevant SNPs. In other words, certain SNPs that through study, and it's quite a young science, through study they've realized that certain gene SNPs influence longevity more than other ones. And these are the gene SNPs that they actually measure. So when we look at SNPs in action, in other words, what is the influence on the body? It affects essential enzymes, as I've mentioned, and it has, for example, a very big role in issues like detoxification, our risks of cancer, our risks of heart disease, whether or not we're going to be obese, issues like that. Now, in the past, what would happen was, let's say, for example, you had a history of let's say heart disease in your family, and you were wondering, am I somebody in the family who's going to have a heart attack? What would happen is that the medical profession would wait until you have the heart attack or you have a heart issue before they start addressing it. But if you look at your genes, you can actually see whether or not you are someone who is maybe has a higher risk of, say, heart disease or cancer or Alzheimer's, and you can start addressing that before it becomes a problem. Now, the sort of trends that come from the SNPs, detoxification I've mentioned, our oxidation capacity, our risks of cancer, mood disorders, whether or not we tend to be prone to depression, for example, or anxiety, our inflammatory capacity. Now, one must remember that all non-communicable diseases, so that would be heart disease, cancer, Alzheimer's, osteoporosis, stroke, for example, are all grounded in inflammation. So if you've got gene SNPs or a lot of gene SNPs that influence inflammation, it's a good idea to know early so that you can actually take steps to mitigate that. Dietary influence, in other words, are you somebody who struggles with sugars, for example, or are you somebody that shouldn't go on a ketogenic diet? And cognitive risks. So do you have risks of developing cancer? Risks of developing Alzheimer's. So when you look at your gene profiles and the SNPs, we look at things like your thyroid issues, mood and stress, Alzheimer's risks, as I've mentioned, hormone detoxification. In other words, for example, if you build up estrogen, a buildup of estrogen is going to increase your risk of estrogen-dependent cancers like breast cancer. Insulin impact, what are your risks of developing diabetes, histamine sensitivity, any intestinal permeability, vitamin D impact, cholesterol impact, and as I've mentioned, inflammatory risk as well. So we look at the clinically relevant SNPs. So for example, we look at certain clinically relevant SNPs associated with cancer. We look at clinically relevant SNPs that are associated with your risk of developing obesity, anxiety, depression, poor detoxification, I've mentioned, chronic fatigue, ADD, ADHD, insomnia, joint pain, increased risk of breast cancer or prostate cancer, whether or not you're prone to develop mood disorders like bipolar, allergies, eczema, any addictive tendency. We also look at whether or not you inherited the hemochromatosis gene. So in other words, does your body release iron or hold onto iron? And in fact, iron overload is associated with a lot of deleterious conditions. So for example, diabetes, elevated blood sugar. So your pancreas is affected by iron overload, premature death, liver problems, metabolic problems, osteoporosis, heart disease, bone pain, jaundice, impotence, hearing loss. All of these are associated with iron overload. And if, for example, we see you've got the hemochromatosis gene, we can then say, okay, listen, you need to watch this. So once a year, you would go and have your iron levels tested. And if they were too high, then the easiest and quickest way is to just go and donate blood. But it's good to see, because otherwise, how would you know what to test if you don't know what your trends might be? So practically, what does this mean? It means that our genes are not necessarily our destiny. It means we can take steps to mitigate the effect of our genes if we know where to go, we know in which direction to go. And we can make lifestyle changes. So for example, obesity is an issue, smoking, alcohol, sedentary life, in other words, if you're not exercising, and toxin exposure. These are all things that we know, okay, is it very, very important for me to stay slim? Is it very important for me to give up smoking or alcohol? Because we can see in the genes whether or not the combination of your lifestyle and that particular gene SNP is going to have a greater impact in you than it might in somebody who hasn't inherited that particular gene SNP. So I hope this has helped. If you've got any questions, please don't hesitate to contact us. We'd love to hear from you.